Hi everybody, I'm Chris with Hands-on Rapid Innovation. So tonight we're going to do a quick tutorial on how to use some 3D CAD tools that are currently available to you at either low cost or free. And really the motivation behind teaching you this stuff is so that you can make a physical market test, whether it is a widget to hold your pen in a base. Maybe you'd find it at a receptionist desk. Maybe you want to make some sort of clamp, or maybe you want to make a headphone wrapper sort of tool here. You need to have some skills to turn a 2D sketch into a 3D object. So let's get started. I want to show you a handful of tools that are currently available to you. First one we're looking at here is Tinkercad. It's been out in the market for over a year now, but was recently acquired, or at least some sort of involvement with Autodesk. So that's Tinkercad. That's one we're actually going to spotlight tonight in this tutorial. Actually, I'm going to turn off this volume here. But on top of that, I just wanted to show you a couple other options that you can look at that may have some other features that may help you enable your concept. Shapesmith.net is an open source 3D CAD modeler as well, very similar to Tinkercad. Again, they all typically have some sort of tutorial involved, so you can watch these things. I'll try to highlight some of the main areas that you'll want to focus on when you're doing your market test prototypes. But anyhow, Autodesk 123D app.com. They have several different apps here that you can start getting involved with. 123D Catch is an iPhone app for your iPhone or iPod Touch or iPad that allows you to take anywhere between 24 to 40 photos and turn those photos into a 3D CAD model. 123D Design is going to be very similar to Tinkercad that we're going to cover tonight. 123D Creature, Make, Sculpt, and the Sandbox. Those are kind of very tailored to some specific projects, but nevertheless very fun to use. Now, if you don't feel like watching this video over and over again, you want to see a list of stuff, you can always go to our website here and go to our tools, Designing in 3D with CAD, and you'll have all the links and some blurbs on that stuff as well. So let's go ahead and get involved with Tinkercad. You need to sign up for an account. You know, I've already done that, so I'm gonna go ahead and sign in. Okay, so now we're logged into tinkercad.com, and you can see a couple parts I already have there. But let me just remind you really quickly what the whole strategy is here. Okay, so let's just go over why exactly you need a CAD file. Okay, if you're trying to make a hardware piece, you're going to need a CAD file because that's the kind of language you use to talk to manufacturers. It's the language you use to talk to 3D printers. And believe it or not, you don't have to be an engineer to get started with CAD tools. Okay, so this is the process we're going to cover in our 3D printing tutorial. And the first step of that typically is CAD, which we're covering in this tutorial, computer aided design. But before you do your CAD drawing, it's actually better to do a quick sketch on pen and paper. So what you see I'm designing here is a refrigerator magnet that will have a hook on it. Some of the key things you want to include are dimensions. You can describe what the key elements are, the features. Here I'm drawing some dimensions for the neodymium magnets we're going to put inside of it. Again, maybe you farm this out to a design shop. But if you don't, you'll be ready for CAD. So let's get started. Okay, so now we're into the main dashboard. Again, this is my second time ever using this, so you're going to see how easy this tool is. But we're going to create a new design. What it's going to do here is it should hopefully ask me to start CADing. Alright, so it's already auto-titled my project. Just so you know, here's the main build platform / they call it a work plane. If I right mouse click, I can rotate that plane. If I left mouse click, I highlight things. If I push down with my scroll wheel, I can translate back and forth. If I scroll up and down, I zoom in and out. Okay, so remind you, we're just trying to build this magnet sort of thing, a magnet hook for your refrigerator. Basically, it's a square box, so I'm going to take a box. I'm going to put a square box in here. But we also want to have our magnets kind of built inside of it, right? So I'm going to shrink this thing down. You can see how big it gets, right? So 30 millimeters, that's about, I think I wanted about an inch. So about 25 millimeters, about an inch. So we'll do 30 millimeters. It doesn't need to be very wide unless we were going to do like 2 hooks. So we'll just, it looks like a nice aspect ratio. There we go, 2 to 1. There we go. And then, so there's our main platform, right? So pretty easy. That's what our shape's gonna be. Now I need to cut out a couple holes. Let's see, how does this work? Scroll here. Actually, what I can do is I can make this a little bigger. And I'm gonna change the work plane. So now I'm working on the top surface. I'm gonna cut some holes out of things here. So that's obviously too big of a hole, right? So we're going to make it smaller by grabbing these little holes. If I hold shift, it keeps everything proportional. I need this thing to be about 6. So it's auto snapping to it's auto snapping to 1 millimeter. It looks like I can change it to probably 0.1, half, quarter. It all depends on what you want, right? Readjusting this guy so it's back at the origin. One thing I wish was a little bit more intuitive about this is just centering things up. It probably is, I just don't know how to do it. Okay. Oop, but you know what I did? I want to turn that into a hole, right? So I just selected hole. So we're going to speed things up just a little bit. As you can see, I'm just trying to get the position of the hole correct and then also get the depth of the cut correct. Not doing very well with this, am I? So the basic premise of the program is you drag out a block or a shape, you pick a work plane to edit, and then you build on top of that plane or cut holes out. It's fairly simple, fairly straightforward, and it's a repetitive process. Okay, that's good. And I want to do another one to mirror. So you just want to keep in mind that Tinkercad and other tools like it are really here for you to sort of brainstorm and describe a 3D shape in a way that's, you can send to somebody online, you can show this to a manufacturer, or like we're trying to do in this case, we're going to send this to a 3D printer. Again, it's not that complicated. There's going to be times where you're going to want to have very precise dimensions, but in this case, as you can see, it's not super precise. We're just trying to get some magnets inside of a block and put a little hook on it. Tinkercad's fairly versatile, and then there's tons of tutorials online. So if you don't get what you need to out of this tutorial, check out their website at www.tinkercad.com. So now we're done with our part, and we want to save this as an STL file, which says there, download for 3D printing, and I'll pick the STL file. Now what we're doing is we're going into a software called a Repetier, looks like Repetier, and what this program does is it basically turns your STL file, your CAD file, into a series of 2D drawings that the machine is going to print. It basically converts your CAD drawing into something that the 3D printer can read. Anyway, we'll cover this in a different tutorial, but the G-code is now generated. You can see the shape turned blue, and now we're going to go into 3D printing. So you'll see here that I pop in the 2 neodymium magnets while it's printing. I pause the machine, and then the rest is taken care of by the machine. So there you have it. There's our little refrigerator magnet. We'll see if it actually holds anything. The magnets are embedded inside, and let's go try it out. Well, sticks there, but I don't think it's going to hold anything. It's pretty weak. Very weak. Well, there you go. You can at least show someone, hey, would you buy that? And if so, how much? And you saw how much work that took. Very little. With Tinkercad, And a 3D printer, I had a new idea concept printed in my hands in less than probably 20 minutes. So I know you all don't have 3D printers, but you do have access to them, and you do have access to Tinkercad right now. So what are you waiting for? Get started 3D CADing. All right? Cheers.